Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 5.1, which is going to deal with understanding linear functions. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to define and identify what a linear function is. Now, back in Module 3, we talked about what made something a function or not. And that determination was that for every x value, it was paired with exactly one y value, meaning x could not repeat with different y values. Now today we're going to be taking a look at linear functions, not just functions, and what a linear function is it is a line, okay, linear line. So we're looking at today if our graphs or if our equations represent a linear function, and if it forms a straight line. So, with that said, we're going to get into our notes for today. And before we jump into an example, let's go ahead and take a look at some information first. Alright, a race car can travel up to 210 miles per hour. If the car could travel continuously at this speed, y equals 210x gives the number of miles y that the car would travel in x hours. So what this function is going to do is tell us how far the car travels in miles after a certain amount of hours. So that's what this y equals 210x represents. The graph to the right shows the situation. So after 1 hour, the car's gone 210 miles. After 2 hours, it's gone 420, 3, 630, and so on. So what this equation does is tell us how many miles it goes after x hours. And if you notice, if I were to go through and connect all the points, it would form a straight line. So because it forms a straight line, that means that this graph is linear. And that means that this function is also linear. Now, the graph is a function because for every x value, it's paired with exactly one y value. And because the graph is a non-vertical straight line, it is a linear function. So something is linear if it is a straight line and it's not straight up and down. Okay? If your graph is straight up and down, that's not considered a linear function. It's a line, but it's not a function. So something to keep in mind today. So the graph needs to be a straight line, but it needs to not be a vertical, straight up and down line. Now, it can be horizontal, straight across left to right. It can have a slope to it, just can't be straight up and down. So that's how we determine something based off of a graph, if it's linear or not. Next, I want to take a look at how to determine it based off of its equation. So that is what I'm going to talk about next. All right. Any linear function can be represented by a linear equation. So it means any graph that is a line can be represented by an equation. A linear equation is any equation that can be written in the standard form expressed below. So the standard form of a linear equation is this right here. ax plus by equals c, where a, b, and c are real numbers, and a and b cannot both be 0. So a few things. Okay, it can be written in this form. It does not mean that it has to be written in the form of, say, 2x plus 3y equals 6. It doesn't have to be written in that form. It just means that it can be. So there's other forms that it can be written in. You're probably most used to slope-intercept form. There's also point-slope form. So those are okay as well. There's just a few things that we have to know or see in our equations to make something a linear equation. So one thing is the equation has to have y. So it has to have y in the equation for it to be a linear equation, if y is not involved in the problem, it is not linear. Next, x and y cannot have an exponent or be on the bottom part of a fraction. So let's start it with x and y can't have exponent. So they cannot have an exponent, so it cannot be x to the power of 2, y to the power of 2, to the power of 3, 4, whatever. They cannot have an exponent. And then lastly, x and y can't be on the bottom of a fraction. So it cannot be on the bottom of a fraction. So I know that one kind of goes on for a little bit. But those are the three things that you need to look for. I don't care about the number in front of x or y, if it has a number, if it doesn't have a number. I don't care if there's plus or minus a number attached to x or y. What I need to know is, does the equation, does it have a y? So it has to have a y. X and y cannot have an exponent, and x and y cannot be on the bottom part of a fraction. If it's on the top part of a fraction or it's next to a fraction, that's okay. It just cannot be on the bottom of a fraction. So keeping that in mind, that is going to guide our direction for example 1. So example 1 is going to ask us to determine if each equation is linear or not. So I'm going to move this over a touch. All right. So we have to determine if for parts A, B, C, and D, if the equation they give us is linear or not. So we're going to run through these three ideas to determine if we have a linear function. So for example 1a, we have y equals 5x plus 2. So let's run through my series of questions. So first one, does it have a y? It does have a y, so we're good there. If x and y are involved, it cannot have an exponent on it. If we look at y and x, is there an exponent on x or y? There is not, so we have passed the second part. The third part is that x and y cannot be on the bottom part of a fraction. Are x and y on the bottom part of a fraction? They're not, therefore I have successfully accomplished all three parts, thus telling me that this is a linear equation. And that is my answer for A. Now, if we look at B, for B we have y equals 2x to the power of 2 plus 1. So, does my equation have a y? It does. If x and y are involved, they cannot have an exponent. Y does not have an exponent, but x does have an exponent to the power of 2. So because that's to the power of 2, that fails that part, so that means this is not a linear equation, so it's not linear. Okay, this particular one would result in a parabola, which is a U shape. It's not a straight line. All right, for C, okay, first thing, does it have a y? It does have a y. Do x and y have an exponent? X or y does have an exponent. So I instantly know that this is not linear because I cannot have y to the power of 2. Okay, x and y cannot have an exponent. And then I just want to highlight real quick that x and y cannot be on the bottom part of a fraction. Well, x is on the bottom part of this fraction here. Therefore, that also makes this not linear. So because y is to the power of 2 and x is on the bottom part of a fraction, that violates 2 out of the 3, and it only has to violate 1. Therefore, this is not linear. Now, if we look at D, for D we have y equals 3. Is y in the problem? Yes. Do x and y have an exponent? Y does not have an exponent. Now there is no x, but it doesn't have to require x. So it passes the second part. X and y cannot be on the bottom part of a fraction. Is y on the bottom part of a fraction? It's not. Therefore, this is a linear function. So anytime that you have y equals a number, that does result in it being linear. If I had x equals 3, because this doesn't have a y, that means that this is not a linear function. It's a line, it's just not a function because it violates the rules of a function for that there's more than one output for one input. Alright, so that is how we're going to go through and determine whether an equation is linear or not. So keep that idea in mind, that it has to have a y, x and y cannot have an exponent, x and y cannot be on the bottom part of a fraction. If those 3 things pass, then you do have a linear function. Alright, now with example 2, it's going to ask us to determine if the function is linear or not, and if it is, it wants us to go through and graph the linear function. So for example 2a, we have 2x plus y equals 4. So is y involved in the problem? It is. X and y, do they have an exponent? They do not, so that passes. And then x and y, are they on the bottom part of a fraction? They are not. That means that this is a linear function. And because I have said it is linear, we do need to go through and graph it. If I said it was not linear, then I wouldn't have to graph it. Now, because it's linear, so far in terms of graphing, we've talked about using XY tables. Tomorrow in section 5.2, we'll start looking at some shortcuts to graphing. But before we get into that, we need to use our table today. Now, XY table, we're going to go through and use to graph this equation. Now, normally with an XY table, I'd usually have you use 4 points. But to form a graph, you only need 2 points. And that's really all I'm going to worry about for today. So I'm going to use 0 for x. And I'm also going to use 2 for x. So that's going to give me 2 points when I plug in 0 and 2 for x. And then I can go through and plot my line. You only need 2 points to form a line. As you should notice when you do it on the computer, you only need to worry about 2 points. Anything more than 2 is just being super specific. Alright, so if I plug 0 in for x, okay, so back in Module 3 when we did this, we would take our equation, this 2x plus y equals 4. So I would take 0 and plug it in for x. So we're going to have 2 times 0 plus y equals 4. 2 times 0 is 0. So I have 0 plus y equals 4. And I can subtract the 0, or I can just imagine the fact that 0 goes away, because anything plus 0 is itself. So that means I end up with y equaling 4. So when x is 0, y equals 4. Now the next part is I chose 2 for x. So if I were to plug 2 in for x, I would have 2 times 2 plus y equals 4. So 2 times 2 is 4. So I have 4 plus y equals 4. To solve for y, I need to subtract this 4 to both sides. And I end up with y equaling 4 minus 4 is 0. So y is going to equal 0 when x equals 2. So I have my 2 points. By all means, if you want to go through and plug in more points, say 1 and 4 or 3 for x, you can. I only need 2 points to form a line, so I have my 2 points now. So my first point is 0, 4, so 0, 4. And then I have 2, 0, so I'm going to go over 2. And I just stay put because it's 0. We just connect my points. And I have my line. So that is the graph for my answer for part A. Plugged in 0 and 2 to find my y values for my 2 points. Plotted my 2 points, drew my line. Is this a line? Yes, it is a straight line, which matches the fact that this is linear. All right, let's take a look at B. For B, again, first we have to determine if it is linear or not. So we have a negative 4x squared plus y equals 11. So if I run through the 3 questions, first of all, does this have a y? It does. Is x or y to the power of anything? I have x to the power of 2. Because I have x to the power of 2, this violates that second part. So that means this is not linear. Now, because it's not linear, this problem only wanted me to graph if it was linear. So that means I am done with that question. So because it's not linear, because I have x to the power of 2, it's not a straight line, and I don't need to graph it. So that is my answer for part B. All right, now example 2 does continue on the back side, where you have to go through and determine, first of all, if it is a linear equation or not. And if it is, you'd have to go through and graph it. Now, I'm not going to run through and do every part of C and D. You can use my notes as a reference for that, the completed notes. But I do want to talk about if it's linear or not. If we look at C, it has y. X and y are not, x and y do not have an exponent, but x is on the bottom part of a fraction, so that means this is not linear. Oh, my boxing just got weird. So that means C is not linear because x is on the bottom part of a fraction. Yes, I have y. Yes, x and y do not have an exponent, but because x is on the bottom part, that means that these are not linear. All right, if we look at D, for D, I have y. X and y do not have an exponent, and x and y are not on a bottom part of a fraction. Therefore, this is a linear function. And in terms of the homework, you would have to go through and graph this. So you would just go through and choose 2 points. You can use 0 and 2 if you want. Plug them in for x, solve for y. Once you have your y, those are your points, plot them, draw your line. And that is how you do example 2. So by now you should feel pretty good about determining if an equation is linear or not. Remember that it has to have a y, x and y cannot have an exponent, and x and y cannot be on the bottom part of a fraction. If it fulfills all those, like part D, it's linear. If it doesn't, like part C, it's not linear. Okay, so that is it for example 2. Now, example 3 is going to ask us to determine if something is discrete or continuous. So first we need to reference back and think back to what makes something discrete or continuous. So that's what we're going to talk about first before we jump into example 3. Now, a discrete graph is a function whose graph has unconnected points. So remember, discrete is just a graph that has a bunch of points, while a continuous is a function that has a continuous graph or it has a line. So anything that you can draw a line is continuous. Anything that is just a bunch of points is discrete. Now, something to think about, because I'm going to give you a situation and ask you if it's continuous or discrete. I'm not going to give you a graph for these. Now, a function representing the sale of individual apples is discrete because there's no fractional part of an apple that can be represented in a table of graph. Meaning, if I'm selling apples, I cannot sell half an apple. I cannot sell a third of an apple or 3/4 of an apple. Okay, I can only sell an apple, 2 apples, 3 apples, 4 apples. So, something is discrete if you cannot have a fractional part of something. And I just lost what I wanted. Because you cannot have a fractional part. So anytime that you cannot have a fractional part, that refers to it being discrete. Now, continuous is when you can. So a function representing the sale of apples by the pound is a continuous function because any fractional part of a pound can be represented. So anytime that you can have a fractional or part of something, okay, I can have a full pound, I can have 2 pounds, 3 pounds, but I can also have half a pound, 3/4 of a pound, and so on. So because I can have a fractional part, that means my graph is a continuous function. So anytime you cannot have half or part of something, that is discrete. Anytime that you can, that is continuous. So using that idea and that logic, we're going to run through example 3, which asks us to determine if the situation is discrete or continuous. So for example 3a, it states the number of soccer balls manufactured per day. Can I manufacture half a soccer ball? No, I cannot manufacture part of a soccer ball, whether it's half, 3/4, or a fourth. So because I cannot have half of a soccer ball, that means that this is discrete. Now, I can have half a day, but because I cannot have half of a soccer ball, that's what makes it discrete. Alright, if we look at B, so we have y equals 2 to the power 3 x, where x is time and y is pints of water. So, can you have partial time? Can I have a half hour? Yes. So I can have half the amount of time, so I can have fractional part. Can you have a fractional amount of water? Can I have half a pint, 3/4 of a pint, 1 pint, 2 pint? Yes, because I can have a fractional part of pints. That makes this a continuous function. Alright, if we look at C, so the number of bullseyes scored for each hour of practice. Now, can I have fractional time? Yes. I can have half an hour, 3/4 an hour, quarter of an hour. Can I have half a bullseye? Okay. No, because it's either you have a bullseye or no bullseyes. So that means this is discrete because I cannot have half a bullseye. It's an all or nothing thing. So I can have 1 bullseye, 2 bullseye, 3 bullseyes, 4, and so on, but you cannot have 3.5 bullseyes. It's all or nothing. All right, and then lastly, if we look at D, if I have y equals 61, x to the power 4, where x is distance, can I have half a distance? Let's think miles. Can you have half a mile, 3/4 mile, or 1/4 of a mile? You can. So you can have fractional distance and then height. And I have half a foot, half or 3/4 a foot, etc. I can have fractional height. So because I can have, say, half a mile or half a foot, that means that this is continuous. So that is all that you need to ask yourself, is if you can have half or 3/4 or 1/4 of something. If you can, that makes it continuous. If you can't, that makes it discrete. All right, so with that said, we have one final example for today, and that is example 4. Now, example 4 is going to ask us to go through and graph the function and give its domain and range. So first of all, Elsa rents a booth in her grandfather's mall to open an umbrella stand. She pays $6 to her grandfather for each umbrella she sells. An amount Elsa pays is given by f of x equals 6x, where x is the number of umbrellas. So they want us to go through and fill in the table and then graph our line. Now, if we go through and plug 0, 1, 2, 3, and 4 in for x, that means we're going to do 6 times all of these numbers. So 6 times 0, 6 times 1, and so on. So we're going to go ahead and grab our calculator, and we're going to go through and figure these out. So our equation is 6x, which means I need to go through and do 6 times my values for x. So first of all, I'm going to do 6 times 0, which gives me 0. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. And 6 times 4 is 24. Okay, so I now have my table. So let's go through and plot our points real quick. So 0, 0, 1, 6, 2, 12, 3, 18, and then 4, 24. Now, usually at this point, this is where we go through, pull out our ruler, and connect the dots. But my question to you is this. Okay, we have to determine if this is continuous or discrete. If it's continuous, excuse me, I can go through and connect my points. If it's discrete, I cannot. Now, the question you have to ask yourself, can I sell half an umbrella? Okay, I cannot sell half an umbrella, so that means that this is a discrete graph, which means it's just made up of points. So that means that is my final answer for this. Remember, domain is x, range is your y, and that accomplishes our work for example 4. So, with that said, that is it for section 5.1 on understanding linear functions. Remember, linear functions form a straight line. Okay, and our graph needs to be a non-vertical, so it cannot be straight up and down, but it needs to be a straight line. And remember, for the equation, it has to have y. X and y cannot be to the power of something, and x and y cannot be on the bottom part of a fraction. So that's what a linear function looks like on a graph, and what its equation looks like. So, with that said, that is it for section 5.1. If you have any questions, by all means, let me know next time you see me or shoot me an email. Be sure to use my completed notes as a reference while you work on the homework. And that is it for today. So thank you for listening. I hope you have a great day, and I'll talk to you guys later. All right, bye.